Interactive artifact that we have chosen is called What Plants Need. At the beginning of the activity, the children are verbally given a mission to make their plant thrive.
Greetings, genomics explorers. Welcome to the future of plant biology, a state-of-the-art digital lab where you're responsible for discovering how to make plants survive and thrive. This lab contains a dying plant. Your mission is to figure out how to keep it alive. Use the controls to alter the environment by changing the lighting, atmosphere, and soil. Explore the cellular organelles and discover clues for the correct combination. Use the notebook to record what happens and to remember clues. If you get lost or are in trouble, just click on the help button. Good luck. We're all counting on you.
After the explanation of this activity, the participant is brought into a science lab where they can conduct their experiment. The purpose of this activity allows students to experiment with a range of different liquids, gases, and types of light in order to create an environment that is suitable for the plant to grow. With reference to the plant's life bar at the bottom of the screen, the effect that each item has on the plant can be identified. Information is also provided for the children to read in relation to the type of gas, liquid, or light that was used by outlining an explanation of facts that provide extra hints of how this affected the plant and its environment. Participants can also move into another area of the lab where they can choose to have a magnified view of the changes that are occurring in the cells of the plant. Extra information is provided here to outline what different parts of the cells do within the plant and how this would look if it was magnified.
This resource incorporates real-world connections in a number of ways. The two most effective connections we have identified is that it lists a variety of gases, liquids, and types of light that are immediately present in our environment, and also shows realistic effects and outcomes for the plant as they are used. As each of these is trialled by the student, visual cues are shown of how the plant has reacted to these, both with a positive or negative change to the appearance of the plant. This would naturally happen in a real-life situation if the experiment was conducted with real elements in a controlled environment. As visual changes occur to the plant, movement on the life bar also occurs. The life bar of the plant, the life bar represents three major stages of how the plant is responding, dying, alive, or thriving.
We have identified that this interactive activity is appropriate for science under the substrand Living World, which provides a relevant exploration activity relevant to the outcome, which outlines that students need to describe some physical conditions of the environment and how these affect the growth and survival of living things. With this activity, students are able to use the given data to develop explanations about how changing the physical conditions of the environment affect the growth and survival of living things. This directly linked to the New South Wales K-10 science syllabus. The activity provides each child with their own plant to experiment with, rather than an educator having to provide real resources for students that would be wasted and are more time-consuming to conduct an experiment with. The children are also able to move at their own pace by responding to the visual cues provided from the plant and the life bar. By modifying the environment and the use of extra information provided to find out more about the needs of the plant and the effect these are having in the cells of the organism. The English reading and viewing strand is also incorporated as the student uses a range of skills, strategies, and knowledge to read, view, and comprehend a wide range of text in this activity.
There are a number of elements from the quality teaching framework that are evident in this use of this activity. Traditional teacher-centered methods are no longer adequate for today's generation of younger learners, so incorporating ICT into the classroom will provide a familiar tool for learning and one which provides multiple opportunities for learning to occur. In regards to intellectual quality, we have identified three elements that were evident: deep understanding, higher order thinking, and meta-language. For the quality learning environment, we discovered two elements that were embedded in this activity: engagement and self-regulation. In regards to significance, we found that background knowledge and connectedness were evident.
The element that we found to be the most important that was evident in this interactive and that will be carried on to Assignment 2 is deep understanding. The Quality Teaching Practice Guide outlines this element as involving the learning that students demonstrate. It also specifies that deep understanding allows students to explore relationships, solve problems, construct explanations, and draw conclusions that may require a depth of knowledge of the specialist content.